Start recording. Good morning, dear students. Today we will do the programming of SOFM. Before that, as usual, we'll have a very quick thought for the day. Be your best, not the copy of the best of others. Okay. I hope you understood the meaning. Don't copy others, but do your best. The different students or different individual have their own best, so don't copy them. Instead, do your best. Everything, do it in your own way. Okay, with this thought we will start today's practical. Before that, a very quick review of yesterday's algorithm and practical, then you will understand very easily. If you have any doubt, you can unmute yourselves and you can ask. Okay, the first one, okay, in yesterday's class what we have discussed was SOFM. SOFM is self-organization, meaning is it's an unsupervised learning algorithm. Okay, either we can call it as SOM or we can call it as, very quickly we'll go, SOFM. What is SOM stands for? Self-organizing feature map. The self itself indicates that it is doing by itself. It belongs to the category of competitive network and it is unsupervised learning. That is, no need of human intervention is needed. These are all, I hope you understood. Then next one is feature mapping. What is actually feature mapping? It is the process which converts the pattern of arbitrary dimensionality into a response of 1D or 2D arrays of neurons. Meaning is that we are reducing the dimensionality and preserving the neighborhood relations of the input pattern. That is how we are doing that. That is what we are going to. Either 1D map means one layer will be there. So everything will be mapped to each and every neuron will be mapped to the respective neurons in the layer. Similar way, 2D neuron means 2D feature mapping is if an input XB, there will be two layers. Okay, A and B will be mapped. Everything will be mapped. So you can see a kind of like this. This one X1 is mapped to all. X2 is mapped to all neurons. Like that way it will be mapping and it will be finding out the minimum distance. Whatever is having the minimum distance will be the winner. How the winner is based on which minimum distance will be using? Minimum Euclidean distance, square of the minimum Euclidean distance. That is the main crunch of it. So it is a single layer neural network, we could say. The architecture shows that there is no feedback or nothing is compared here. Target is not there. So it's an unsupervised algorithm. So X1 to Xn and Y1 to Ym. All is mapped with all. All is connected with all. That you could see the architecture. Okay, then we will go a little bit faster. Applications and everything we have discussed in yesterday's class. So we will go with the algorithm. In algorithm, first is initialization of the weight. Second, till the stopping condition is there, we have to give the input. Okay, and compute the square of Euclidean distance. Which formula you have to apply, or J. What is J? J is 1 to M. That is nothing but the output. Okay, so D of J equal to summation I runs from. This formula is needed. Okay, D of J is equal to, just check. If those who are present there, I hope they might have written this. Those who are absent, for them I am just telling this because this is the crunch of it. Summation I runs from 1 to N and J runs from 1 to M. Okay, Xi minus W I J the whole square. Okay, so this is nothing but we are finding the square of Euclidean distance, and out of this which one is minimum? Suppose I'm having in output, this is output, and there can be 1 or 2 or 3, whatever the inputs. So this will be mapped with this, this will be mapped with this, this will be mapped with this. So all for this one D of 1, all weights and everything will be calculated. D of 1 will be calculated for all. Okay, and whichever is the and D of 2 also will be calculated similar way. Which one is minimum out of this, that will be considered as winner. So there are then winner hone ke baad next task is we have to update the weights. So weight updation formula is this one, all of you should know. Wij new is equal to, this is important, Ij. What is I and J? I input, J is output. Okay, so this will be W11 This will be 1, 2. Okay, 1 to 2. Okay. Wij old plus alpha into xi minus alpha is the learning parameter. Normal equation is Wij new is equal to Wij old plus change in Wij. Okay, this is a common equation. Now in KSOFM, why it is KSOFM? Because it's Cohen, okay, under the name of scientist. KSOM, all are same. Okay, SOM if you say, okay, that is one and the same thing, self-organizing map. SOFM is self-organizing feature map. Since this is invented or by Conan, that's why KSOFM. Okay, all are same. Now this equation is easiest, so map with this equation. Okay, so Wij old plus delta Wij, in this case it is alpha into xi minus Wij. So you could see that here also the same thing, xi minus Wij, here it should be old. Okay, that will be its change in Wij. Okay, change in weight. Okay, so this is how you will be doing. For an example, very quick way I am explaining the example. Yesterday also we have discussed. So we are having 4 inputs, 1, 2, 3, 4 inputs for neurons. Okay, 1, 2, 3, 4. And how many clusters we have to make? We have to make 2 clusters. Okay, somewhere it has mentioned. Yeah, the number of clusters to be formed is 2. So 2 clusters means output is 2. So what we are saying? We are having 4 inputs that we have to categorize in such a way that it belongs to which group. Okay, this one I will assume that 1. Okay, I1. Okay, input 1. This is I2. This is I3. Just for example. Okay, this is I3 input, I4, like that. So which it belongs to which group? That is what we are finding out. So for that, what is the first point in algorithm? Initialize the weight. Either we can randomly initialize or some existing weight we can give. Whatever we have learned previously that we are using. Okay. So here it will be a 4 by 2, what I could say, 4 by 2 vector or matrix or array, whatever the way you want. Okay. So in which you can see that there are 2 columns. So this is j equal to 1 and j equal to 2. This is I equal to, okay, 1, 2, 3, 4. This is, if you understand this, so this will be 1, this will be 2, like that. Okay, so first what we are taking the first input for and we will be finding out the Euclidean distance for that. D of j, which is nothing but d of 1, first we will be finding out. That is I runs from 1 to 4, W I 1. Directly I can write because j is 1. So that equations can be replaced. Here both are there. So some of them may be getting confused. Since I am saying d of 1. So what I can write is j is 1 permanently. So I is 1 to n. Okay, j is 1 to m लिखने का जरूरत नहीं है because j is 1 here. So here now xi minus w1j the whole square. So if you want, you can write it in any way, xi minus wij whole square or wij minus xi, because we are squaring it. Don't get confused with that. So this equations will be writing and will be getting a value of 0.4. Once we get this value of 0.4, next one is d of 2. What is d of 2? Minimum. So this is we are getting 2. So yesterday's class, those who are new, they will be understanding that we have discussed that, okay, in detail. So I am not going in depth of it. So these two will be compared. This is 2.4, the other one is 0.4. So which one is minimum? Minimum is D1. D1 ka value kitna hai? That is 0.4. Correct? This is 0.4. So what we are going to do is j equal to 1. J equal to 1. This is the winner. Then this j equal to 2 nahi hai. So first input vector will be belonging to this. So what is the next step? I have to update the weight. How weight updation formula is what? Wij new equal to wij old plus alpha into xi minus wij old. So all the weight updation will be doing for that. So in this case w 4 will be there. Correct? What are these 4? If you closely observe, this one, this one and this one. Okay, ये updation हो जाएगा. So once we update, so only this column will get updated. Now we will go for the second input. Second input कितना है? This is second input. So second input also will be doing the same way. D of 1 and D of 2 will be calculated, and which one is the smallest? In this case, D of 2 is smallest. So which weight will be updated? The इसका this second इसका weight j equal to 2 का weight will be getting updated. So if you observe, this is the previous one weight, this gets updated now. Then we will take the third input. We will find D of 1 and D of 2, which is minimum Euclidean distance, and we will compare. This is 1.91, this is 1.5. So out of which one is minimum? This is minimum. So j equal to 1, this is minimum. So j equal to 1 is minimum, means this weight I have to update. The rest of the thing, this will be, the second one will be as it is. Which one will get updated? This one will get updated. This one, first one. Okay, similar way we will go with the fourth input. This is for input hai. So D of 1 and D of 2 will be calculated. Which one is minimum out of this? This one, first one itself. So j equal to 1, that particular weight will get updated here. You can see that weight updation formula, and weight will get updated here. So once we get all the inputs, for all 4 inputs we have calculated, it belongs to which output, okay, which group or which cluster. The minimum one is minimum distance, whichever is having, that is its cluster. Okay, once all this is done, what is the last one which we have to do in the algorithm is the learning rate updation. Okay, in learning rate updation, what you have to do, alpha t plus 1, that is new alpha, is equal to 0.5 into old alpha. Okay, so alpha in the beginning we have taken it as 0.5, that's why 0.5 into 0.5, 0.25. So this is the new learning rate. If you have to, this is for one epoch, whatever we are doing. Okay, the same thing we have to do it for many epochs, so that we will get minimum error or the best results. Anybody is having any doubt in this? Now we are going to go with the program. Anybody is having a doubt? I hope nobody is having doubt. Now we are doing the program. Before that, I think we will start with the, this is the fourth experiment. Okay. So in fourth experiment, we have written Conant's self-organizing feature map, that is SOM. So here the theory I'm skipping because we have already discussed a lot. The, this part, algorithm, you have to see. Select the network topology to determine which node are adjacent to each other. Initialize the weights to small random values. Then initialize current, neighborhood distance D of t to a positive number. Then while computational bounds are exceeding the following, we have to do it, or the same algorithm, both the any algorithm you do it, no problem. This is a generalized way of doing it. I have done it in this way. So what is the many thing, if whatever is minimum, that Euclidean distance, that you have to find out. Okay, once you get D1, D2, D3, etc., the minimum one you will find out, and then you will update the particular weight. Okay, where Wi is equal to nu into this one. Fine. Then this can be done it for many iterations. Okay, in practical we are doing it for many iterations. So here I am taking the same example. You could see the same example which we have solved now, and these are the I have already discussed you in yesterday's class also. I have taken the problem from this second book, Principles of Soft Computing by Shivanandam and Deepa. Okay, so that book, the same explanation is given. Now we will start with the program. Program में less number of codes ज़्यादा नहीं है. So first we will go with the, I'll execute as it is. Then we will come with the. So we will go with one epoch. So I am showing that only with one epoch how exactly it is working. So you can see that for one epoch, implement Conant's self-organizing feature map, that SOFM. Input कौन सा वेक्टर है? X दिया है 0 0 1 1 1 0 0 0 1 1 0 0 0 0 0 1. So input देना है and initial learning rate which is alpha. So that you can give it as 0.5, the same thing as in the example. And we are taking the same weight matrix. ये सब आपको directly दे सकते हैं, नहीं तो you can ask from the user and input ले सकते हैं. Both options are available. Now, so that all you know how to take. So initial weight होने के बाद the last one is after doing the program, what we are doing, this is for weight matrix updation for one epoch. Okay, whatever the final answer for the problem which we are getting here, okay, the 0.025 and 0.9 wala, okay, whatever we are getting here, the same thing you should get it here in the output. Okay, and the new learning rate is 0.25. You can see that here also we are saying the same thing. The new learning rate is 0.25. So how we are doing that? If you know one epoch, the other things are just doing it for many epochs. It's very easy doing that. Okay. So we will go with the program now. First one, you know that clear all, close all and all. And first what we have discussed is, first point is input vectors as it is we have given. Can you see anybody is having that? You either ask from the user, accept the input. Okay, then initial learning rate also you can accept. For the time being, what I have done is whatever the problem is having, the same inputs, same weight vector, initial weight vector and same alpha we have taken. Okay, for for this is the d of j find out kar rahe. For how many summation I runs from 1 to 4, j runs from 1 to 2. Correct? So either you can accept I and j, the maximum value. What is the value of I is we have taken it as n. You accept from the user and then you can generalize it and accept the j value, which is the output from the user, which is m value. And accordingly you find out d of j. In next one, what we are doing, d of j equal to minimum of d. So out of this minimum we are taking. And only for that, what we are doing, we are updating the weight. What is the new weight is equal to old weight plus alpha into xi minus w. That's it. Same equation if you see. Okay, this equation is same. Then weight matrix after one epoch. You are displaying the w, you are displaying the new alpha. What is new alpha? New alpha is this 0.5 into alpha. That's it. So you are getting the output. Anybody is having a doubt? We are doing the same thing. So don't need to by heart anything. Only two lines are here. The d of j you have to find and wj. How you have to do it? वो summation का equation. So it's very easy. Now if you are going with what I suggest is you have to do both program, okay, for one epoch as well as for many epochs. Okay. So one epoch as well as for many epochs. Many epochs matlab I'm just showing. So many epoch के लिए क्या करना है? You have to. I'll execute it. We'll see how exactly it is working. So the same thing if you observe, okay, rest everything is same. Input is same. Initial alpha is 0.5. Initial weight matrix is the same. Where the difference lies, you can see the output in which the weight matrix after 300 epoch. So what is the stopping condition which I have given here is 300 epoch. So you can give according to your choice. Okay, so minimum more iterations are required so that the learning rate is improved now. So 0.0313. So in which the weights are updated. It is not the previous weight which we have seen. It is different. So that is why it is machine learning. It is not human learning, because one epochs we can do it. For many epoch within seconds, if you have to do it, you have to go for machines. Anybody is having any doubt in this? So how we have done for loop for that you know here. So what I suggest is I want both the programs to be executed and both the output. That is 0.5 into alpha plus alpha, then epoch equal to epoch plus 1. If epoch equal to 300, then only you stop, otherwise you continue this. And finally, you display the weight matrix for 300 epochs and new learning rate. That's it. Okay, so both the program you have to do it. Okay, both are, there is nothing difference. Why I'm saying, so that you will understand actually how exactly it is working. So it is very simple as this way. I could say first one, it is d of j you have to find, then minimum of d of j you have to find, and that corresponding to that all weight should be updated, and new learning rate is nothing but 0.5 into the old alpha. Okay, so this is how you will be doing. It can be done for both. And how exactly I want, almost everybody is submitting the program only in as a one file, but I could see few of them are submitting separately. Don't submit like that. I want everything in one file. Okay, the write up and the program and the output. Okay, don't submit it separately. I'll just show you the program of it exactly. I'm expecting in this way. Okay, just so first one you can type the program and the output of it. Okay, then you can do the same thing, execute once again for many epochs and the new weight and new learning rate. Okay, so this is how only in one program you have to do both the one Word document or maybe anything, and then merge everything together. Make it only one document, and the question for this is for this define the goal of SOM, why SOM is called a topology preserving map, and list various applications of SOM. So these are the questions and the conclusions you have to write. Anybody is having any doubt regarding this? If not, we will go with the next program. Thank you.